Dear students, now we discuss about self-induction. Inductance is the property of inductors to generate EMF due to the change in current flowing through that circuit or a change in current through a neighboring circuit which it is magnetically linked. Inductance is the property of inductors to generate EMF to the change in current flow through the circuit or change in current through a neighboring circuit. It is magnetically linked. Then next we learn what is self-induction. An electric current flowing through a coil will set up a magnetic field around it. Therefore, the magnetic flux of the magnetic field is linked with that coil itself. If this flux is changed by changing the current and EMF is induced in the same coil, this phenomenon is known as self-induction. An electric current flowing through a coil will set up a magnetic field around it. The magnetic flux of the magnetic field is linked with the coil. This flux is changed by changing the current and EMF is induced in the same coil. This phenomenon is known as self-induction. The EMF is induced is called self-induced EMF. The EMF induced, it is called self-induced EMF. Here, see the diagram in self-induction. What is self-induction? A magnetic flux of the magnetic field is linked with the coil. This flux changed by changing the current and EMF is induced in the same coil. This is known as self-induction. The EMF is induced. It is called self-induced EMF. Then see the derivation here. Phi be the magnetic flux linked with the each turn of the coil of n turns. Then the total flux linked with the coil is n pi b. Pi b is the magnetic flux linked with the each turn. Then n pi b is the total flux linked with the coil. Then this is proportional to the current I in the coil. The total flux linked with the coil n pi b is proportional to the current I in the coil. So we can write n pi b directly proportional to I. N pi b directly proportional to I. Here we taking a constant. So we can write n pi b is equal to Li. N pi b is equal to Li. Then next we find the value L. We can write L is equal to n pi b by I. L is equal to n pi b by I. Here L is the inductance. L is the self-inductance. Then if I is 1 ampere, then L is n pi b. If we give the value I is 1 ampere, then we will get the L value. L is equal to n pi b. Then next we learn self-inductance or simply inductance. See the definition. Self-inductance or simply inductance of a coil is defined as the flux linkage with the coil when 1 ampere current flows through it. Self-inductance or simply inductance of coil is defined the flux linkage with the coil when 1 ampere current flow through it. This is known as self-inductance. When the current I changes with the time and EMF is induced, from Faraday's law, the electromagnetic induction, this induced EMF in the coil is given by, we can write epsilon is equal to minus d n pi b by dt. The equation epsilon is equal to minus d n pi b by dt. Then we already know the value n pi b. So we can write what is the value of n pi b? N pi b is equal to Li. So we can write minus d into Li divided by dt. Minus d into Li d divided by dt. Then next we write epsilon is equal to minus L di by dt. Epsilon is equal to minus L into di by dt. Here also we find the value L. So we can write L is equal to epsilon divided by di by dt. L is equal to epsilon divided by di divided by dt. The negative sign in the above equation is the self-induced EMF always opposes the change in the current with respect to the time. The negative sign indicates the self-induced EMF always opposes the change in current with respect to time. Then next we learn Next we see the definition inductance of a coil. Inductance of a coil. What is inductance of a coil? Inductance of a coil is defined as the opposing EMF induced in the coil when the rate of change of current through the coil is 1 ampere second minus 1. The inductance of a coil is defined as the opposing EMF induced in the coil when the rate of change of current through the coil is 1 ampere second minus 1. Then next we see the unit of inductance. Unit of inductance. Inductance is a scalar unit. Inductance is a scalar unit. The unit is Weber ampere minus 1 or Vs ampere minus 1. The unit of inductance is Wb is we called Weber. So Weber ampere minus 1 or Vs ampere minus 1. It is also measured in a Henry. Then 1 Henry is 1 Weber ampere minus 1 equal to 1 Vs ampere minus 1. 1 Henry is 1 Weber ampere minus 1 is equal to 1 Vs ampere minus 1. Then the dimensional formula of inductance is M L power 2 T power minus 2 A power minus 2. The dimensional formula of inductance is M L2 T power minus 2 A power minus 2. Then next we see the definition. What is Henry? Next will we see what is Henry. The inductance of the coil is said to be an 1 Henry if a current of 1 ampere produce unit flux linkage in the coil. What is 1 Henry? The inductance of the coil is said to be 1 Henry if a current of 1 ampere produces unit flux linkage in the coil. What is 1 Henry? If 1 Henry if a current of 1 ampere produce unit flux linkage in the coil. It is called what? 1 Henry. If di by dt is 1 ampere second minus 1, epsilon is minus 1 volt, then L is equal to 1 Henry. The next we also another definition of 1 Henry. The inductance of the coil is 1 Henry if a current changing at the rate of 1 ampere second minus 1 induces an opposing EMF of 1 volt in it. Another definition is the inductance of the coil is 1 Henry if a current changing at the rate of 1 ampere second minus 1 opposing EMF of 1 volt in it. This is known as another 1 Henry definition.